Hello everyone. Today I will share with you a quick walkthrough of using a deep learning image segmentation model trained with MONAI within MATLAB using the Python interface. MONAI is a popular Python package which includes several tools for medical imaging. Let's jump right in. Medical images help clinicians visualize various images of parts of the body for diagnostic or treatment purposes. Image segmentation is a process by which one can classify each pixel in an image into categories of interest. For example, in brain magnetic resonance images, one could categorize each region into its anatomical group, white matter, gray matter, and so on. Based on this, physicians can make a better diagnosis of Alzheimer's disease and make appropriate treatment plans, as it is known that white matter shrinks in case of disease. Determining this size automatically using a computer program depends strongly on the quality of segmentation algorithms used. Errors here would not be well tolerated. In this video, we will go over how to use a pre-trained deep learning segmentation model from MONAI to segment the left atrium of the heart using MRI data. We first read in the image and the ground truth segmentation labels using the nifty read function and then visualize the data using the volume segmenter app. The MATLAB volume segmenter app allows easy interactive segmentation of medical images by providing tools for creating and refining segmentation masks. We use this app to visualize both the images and the labels to review what we are going to train our model with. These images come from the Medical Segmentation Decathlon, a set of 10 different tasks in segmentation with large datasets. This task is to segment the left atrium shown in red. Let's now go into the MONAI GitHub tutorials and train a popular 3D segmentation model called the UNet to integrate it with our analysis pipeline in MATLAB. The UNet model we will use has parameters shown within the green box. To run this yourself, check the link to the repository we created for this video, where you can navigate to MST Heart Training to look at this tutorial adapted to the heart dataset and the parameters we chose earlier. When you run this with your favorite Python IDE, it will create log files with checkpoint versions of the 3 best performing models based on the validation accuracy. You will move one of these files into the models directory and rename it to trained MST heart model.checkpoint and run the inference Python file to verify that it works correctly and produces good results. Now, let's learn how to run this trained model within MATLAB in 3 easy steps. First, you open the test MATLAB MONAI bridge live script and use the pyversion command to point to the Python environment you've created, where you install the dependencies using the requirements.txt file. Instructions on how this is done is available in the README file associated with the repository. Next, you can import the bridge file we have included in the repository called MATLAB MONAI bridge using the import module function from the py.importlib package. Note that the name of the imported module must match the file name. Loading this module makes all the functions in it available to MATLAB within the py.module name namespace. Then you can access Python functions as any other MATLAB function calls within the live script under this namespace. For example, you can create the UNet object using the create model function. Finally, in step 3, you can then call the inference function to run the UNet model on the specified nifty file at the input. To evaluate how well the model performed, you could also measure accuracy using commonly used scores like DICE. In this case, the DICE score is 0.86, which is great given how easy it is to train. This is just one example of how MATLAB and Python can be used together. You can also import models directly into MATLAB by calling the import network from PyTorch function and use the Deep Network Designer app to visualize the layers from the imported model. Really cool, isn't it? In summary, this short video discussed how MATLAB and MONAI can be used together to be as productive as possible for medical image segmentation workflows. The repository includes code and trained models to reproduce this. The description of this video also includes links to other external resources in the MathWorks and MONAI web pages to learn more. Thanks for watching and enjoy!